Let's begin. Today's December 10th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 5 criteria cards. Criteria cards 2, 6, 12, 17, and 19. And the puzzle uses the blue verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 5 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D, and finally criteria card E. Criteria card A takes a look at our first digit, the triangle digit, and the Turing Machine compares it to the number 3. Should the value of triangle be less than 3? Should it be equal to 3? Or should the value of triangle be greater than 3? Criteria card B takes a look at our middle digit, the square digit, and the Turing Machine will let us know whether it's an even digit or an odd digit. Criteria card C takes a look at our first and last digits, triangle and circle, and compare them. Should the value of triangle be less than circle? Should they be equal? Or should the value of triangle be greater than circle? Criteria card D will take a look at the 3-digit solution, and the Turing Machine will let us know how many evens there are. Are there no evens? Is there a single even? Perhaps 2, maybe even all 3 are even. And finally, criteria card E will take a look at our first 2 digits, triangle and square, add them together, and compare the sum to the number 6. So should the sum of the 2 digits be less than 6? Should it be equal to 6? Or should the sum be greater than 6? And remember, the objective of today's puzzle is to find that unique 3-digit code that abides by all the 5 criteria cards we just described. And we're going to start off with an initial proposal of 314. So the first thing I'd like to test is criteria card B. Okay, so the Turing Machine approves of my choice in square. I did pick an odd one, and the Turing Machine confirms that yes, that middle digit should be an odd digit. Let's go ahead and type that up in our notes in section B. And again, we'll say that square is an odd digit. And of course, since it is odd, let's go ahead and cross out the 2 evens in square. So crossing out 2 and 4. Okay. So I think the next thing I'd like to test is criteria card E. Okay, so the Turing Machine again agrees with my proposal. I did pick a 3 for triangle and 1 for square. If I add those up, that gives me a total of 4, and 4 is less than 6. So that's what the Turing Machine confirms, is that the sum of the first 2 digits must be less than 6. So again, let's type that up, and we'll put that in section E. And that is that triangle plus square should be less than 6. Okay, and since the sum of the first 2 digits must be less than 6, what I think we can say is that neither triangle nor square can be a 5, since if you add 5 even to the smallest of ones, that total is already a 6, and obviously anything bigger would make it greater than 6. So yeah, so we can say for certain that neither triangle nor square can be a 5. Let's see, anything else? Let's see, if we add 4, yeah, 4 can be added to 1 to give us a sum that's less than 6, so 4 is still okay, as well as a 3 in square. 3 plus either 1 or 2 will give us a sum that's less than 6. Okay, what else? Just curious about criteria card D, how many evens there might be. Obviously you can't have, I don't think you could have 3 evens, because if you had all of them be even, that would make criteria card B irrelevant. You would know that that would be, square would be even. And then of course there's criteria card C, that's comparing the first and the last digits. Well, let's go ahead and test criteria card C. Okay, so the Turing Machine does not approve of that. Notice that my triangle value 3 is less than my circle value of 4, but since the Turing Machine does not agree with that, that would mean that either triangle and circle are both equal to each other, or that triangle should be greater than circle. So let's go ahead and type that up, and we'll say that in section C, that triangle should be equal to or, I am experiencing a little bit of lag, I apologize. It's going to be equal to or be greater than circle. And so I think for that reason, because of the equal, I don't think we can actually cross out anything, because triangle and circle can be equal to each other. So yeah, I don't think, well, let's see. Yeah, I guess, yeah, circle could still, well, can it be a 5? Maybe circle can't be a 5. Let's think about this. Currently, triangle is not a 5 because of criteria card E, and triangle is not supposed to be less than, so yeah, actually I think we can cross out the 5 in circle, because at the moment triangle can only be a 4, and so yeah, we can cross out the circle in 5, and at the moment then, yeah, 4, triangle 4 can equal circle 4. That is a possibility. So yeah. Okay, well, I believe that does it for this round. We have completed our 3 Turing tests. We're now going into the phase where we'll be discussing how to construct a good second round proposal. So notice we did not test criteria card A, comparing our first digit to the number 3. And it's still a little bit outstanding what triangle and circle should be with respect to each other. Are they equal, or is triangle greater than circle? And again, we did not test criteria card D, finding out how many evens there might be in our solution. So again, knowing that the sum of the first 2 digits must be less than 6, we need to obviously restrict our answer choices based on that. But let's see, very interesting here. Can triangle and circle be the same? Well, we have lots of options. We could have 1s, 2s, 3s, or 4s. If we had, let's see, well, here's another interesting thing. As I mentioned earlier in the video, we can't have 3 evens because we would know that square would be even, making criteria card B irrelevant. I didn't think about this, but if you have 0 evens, that would also inform us something about square, that it would be odd. So yeah, so either we have a single even or even possibly two evens. So it comes down to a 50-50. And so the question is, if there's a single even, where would it go? Obviously, it'd either be triangle or circle, and there really is no mention. I guess you could have two evens and then criteria card C would set them equal to each other, possibly. And perhaps criteria card A would let us know which of the two evens it might be. Less than 3 would be 2, greater than 3 would be 4. So I guess you could have something like 414, since you want the sum to be less than 6. Or perhaps maybe it would be a pair of 2s, and you have to pick between, well, could you pick between 1 and 3? Both of those work, 212 and 232. Both of those options would give you a sum that's less than 6. They both have evens. They're both equal. Yeah, so I don't think it could be a pair of 2s. And again, we don't know, even if we do have two evens, are they even equal? You could have a pair of 4s, and that would basically let you know that square would have to be a 1. That's possible. What about the alternative where they're not equal and perhaps not even both be even? Is there a way to decide that? There are a lot of possibilities. If triangle were to be greater than circle, what would that mean? Could you have 2, 3, 1, a single even? 2, 3, 1, 4, 1, 3. I don't know. There's just so many possibilities. And there's nothing about the ordering of the digits either. So somehow you have to pick that square value. You almost have to force the issue. So it could be that in order to force the issue, maybe you force a triangle to be a 4, which would require you to pick 1. So it'd be 4, 1. And then the question is, so I think that would mean that there'd only be one even, because I don't know how you would pick between 2 and 4. But then again, well, perhaps there are two evens and they are equal. That's the only way you could figure that out. Because in both cases, 1 and 3 are less than circle. So it would almost be like you would have to have two equal digits, two evens. So yeah, let's go ahead and try that. Let's do 414 and see where that takes us. Okay, so just to double check, is that middle digit odd? It is. We could have a first digit that's equal or greater than the last. I chose equal. And yeah, 4 plus 1 is less than 6. Okay, well, let's give that a try. And let's see. Between criteria cards A, C, and D, which one is the most likely to occur? Or which one can we deduce, perhaps, at the end? Well, let's go ahead and test criteria card A. Okay, so it is not true that our value should be greater than 3. Notice that my 4 is greater than 3, but that's not the case. So either triangle is less than 3 or equal to 3. So let's go ahead and type that up. And again, we'll say that triangle is either less than or equal to 3. And so let's see. Yeah, so we can go ahead and cross out that 4 in triangle. Well, that's 1 less even, but again, we're just not quite sure what it could be. And the only thing we can say is that you can't have 3, 3, but I think everything else works. All other kind of combinations currently between triangle and square will give us a sum that's less than 6. Okay, well, is it possible that they are now equal? Triangle and circle. Well, again, I don't think, I'm going to say that no, they can't be equal. Well, no, that's not true. I guess I could pick 3 for triangle and 3 for square, or circle, I should say. Yeah, I still don't know if they can be equal or not. Let's go ahead and test C. Okay, so it's true that they are not equal. So let's go ahead and cross this out. And we'll say that triangle should be greater than circle. So since triangle is to be greater than circle, it looks like circle can't be a 3 or a 4. So yeah, now triangle R3 is greater than 2 and 1. And that would mean that also triangle can't be a 1, because if triangle were 1, there's nothing smaller for circle to be. So it looks like, yeah, now it looks about right. Again, we can't have a combination of 3 and 3. And so let's now see, well, how many evens there might be. So let's test criteria card D. And so no, it is not true that there are 2. It does not approve of that. And as we stated, you can't have 0. So there must be, we'll deduce, we'll type in that we're going to deduce that there is a single even digit. So we'll deduce the solution has a single even. Okay, so we only have a single even. And let's see, what could that be? Well, we could say, well, let's let circle be even. So that forces triangle to be a 3. And so one possibility is 3, 1, 2. But then you could have also 2, 3, 1. Okay, so what? Oh, we don't know what A is. Oh no, we're going to have to go to a third round. Yeah. Let's see, is there any way to deduce 3, 1, 2 or 2, 3, 1? Yeah, I don't think you can deduce that based on everything that we have. Okay, yeah, we're just going to have to go to a third round, unfortunately. And so I will say 2, 3, 1. Let's go with 2, 3, 1. And we're just going to do a quick test on criteria card A, and that is also incorrect. So it's not less than 3, it must be equal. So let's go ahead and cross this out. And so yeah, triangle is 3. So let's go ahead and cross out the 2 in triangle. And of course, the sum of 6 requires us to cross out that 3 in square. And so it's 3, 1. And we do have a single even, and that must be circle. So it looks like our solution is 3, 1, 2. Okay. Well, let's go ahead and verify. See how we did. So 3, 1, 2 as our solution. Well, fantastic. That worked out. Now, how do we do versus a Turing machine? Well, this is a 5 criteria card puzzle, but we did 7 tests in 3 rounds. Don't know if that sounds too promising, but let's take a look. We did do BCE, and that's where our only 2 check marks came in. And then we did ACD, and then A. So we did A and C twice throughout the puzzle. Well, let's see if I can remember all of this. So BCE in the first round, then ACD, and then A. So BCD. Wait, is that right? BCD? No, BCE. Not that it really matters. All this is, it's just verifying the number of check marks. And then I think we did ACD, and all those were incorrect. And then we did A in the third round, and that was still incorrect. Okay, wow, very fortunate. We tied with the Turing machine, and a tie is a win. But look at all those, too few check marks, and all of these X's. Well, we can learn from our mistake. We can learn what to omit, what pathways we can close off to find our solution. Again, we did go to the limit, all the 7 tests, but we still tied versus the Turing machine. Well, what about you? How did you solve? Did you choose a different set of criteria? Were you more efficient? And if you'd like to, please share your thoughts on how you accomplish that in the comments. If you liked the video, please do give it a thumbs up. And of course, don't forget to hit subscribe to not miss out on any future videos. Well, until next time, have a great one.